So we got a little bit further in this hour than the other 2 hours, but I'm going to go on and do it again. Because for the rest of the hours, we stopped with this here using, yep, okay. With unbounded and bounded intervals is where we stopped in the other hours. We covered this already, talking about the different types of intervals that we can have, bounded and unbounded. And for this hour, we went through going and writing each interval in interval notation. We did this yesterday. But when we covered it yesterday, we realized that we didn't have it in the note sheet. Yes. So we kind of y'all follow along. Y'all just watched me do it on the board. So this here is in the new note sheet that's getting printed off. So we can look at those again. Now, so we want to write each interval in interval notation. So when we talk about interval notation, we're talking about using brackets, parentheses, or some combination of the two. Now, if there is a definite start and end, if it is bounded, or we have for inequalities, x is in the middle and we have two numbers on either side, we're going to have two numbers. If it is unbounded, so we only have x and a number, just greater than, less than, it's not in the middle, it means that we're going to have an infinity, either positive or negative. And the same thing is true with graphs, because if the graph goes off to one side, doesn't have a stopping point, it means we're going to have infinity included, either positive infinity or negative. And like C here, that's kind of funny, C here. Sorry. Playing on the word C and the letter C. If you see here, C. It has two endpoints. So that means that we're going to have two specific numbers. We're not going to have infinity. Now, if we look at the first one, A, we can see that there are two endpoints. So in interval notation, we will have the two numbers, -2 and 3, because it is talking about the interval between -2 and 3. Let's see here, which number is this? Page is this? This isn't 17. Yep, I skipped down 2. All right. This is not the note sheet for me, apparently. So all of y'all will have to watch this one. But when we look at this here, because when we talk about two endpoints, those two numbers are going to be the endpoints. Now, is -2 included for this inequality? Well, yes, because it is equal to, so we would write a bracket. 3 is also included because it's equal to, so that would be the interval. So hopefully this is something y'all remember doing in Algebra 1. Any questions on the first one? Besides the fact it's not in the note sheet. Let's look at the next one. So we say x is greater than -1, yes? So we're talking about all the numbers that are greater than -1. So in the interval, the smallest number that we can have is -1. And it's going to increase from there. So the biggest number that we could possibly have is infinity. And we know anytime we do have infinity, it's going to be a parenthesis. Yes. And then on the other side, we would have a, because is -1 included? Does it equal -1? No, so this is also going to be a parenthesis. Because the only time we use brackets is if it is equal to or is included. Included on a number line or is equal to. So you'll be in 2. They're coming. So any questions on letter B? So we can also look at this and use this with graphs themselves. So with the next one, letter C, we do have two definite endpoints, yes? The smaller of the two numbers would go on the left, so the smaller number is comma, and the bigger number is 4. Is -3 included? Yes, because it's filled in, so we would use a. And 4 is not, so it would be a parentheses. So that would be the interval. So, yes. So we would have comma 3 bracket because 3 is the biggest number, so it would go on the right, and it would have a bracket because it's included. What would the smallest number, or the number on the other side, be? Negative infinity, because it extends out indefinitely. Now, if you have trouble writing an infinity number, turn the paper sideways and draw an 8. Same thing. Questions on these here? Okay. Now, set builder uses a set of terms, so we'll look at this and we'll look at several more with this. Now, the overall set builder notation, this seems like it's going to be something that's very complicated, but it's not too much. There's only really 2 or 3 main parts. The first thing is that these will always be set off by braces on either side. So again, this is one of the pages I forgot to include. They will always be set off by braces on either side. We'll have X bar. So for all of these here, and the way that the book does this part here will be included in every single one. And what this says mathematically is the set of all real numbers X such that. This part here is just the description. What are we classifying? What kind of numbers do we have? Because this here is saying X is less than B for whatever number. So if we had, say, a statement like X is less than 6, we would do brace X bar for all real numbers X such that X is less than 6. X less than 6. And then brace, and that's it. If we wanted to talk just about the whole numbers, or say the natural numbers, we would do brace X bar, the set of all real numbers X such that X is a natural number. And we can write that out. So this definitely is not in your notes. X is a natural number. And we want to write this in set builder. We always start out with brace X bar. X is a natural number. That's it. Because we could write this out just, again, X, brace X bar, the set of all real numbers X such that, describe it. Because the other part is going to be the description. Now, are there easier ways to have written this? Yes. Did we have a symbol for natural numbers yesterday? Yeah, it was an N with 2 lines. What we could say, because this is the symbol for natural numbers, yes? Now, this sideways E is saying that X is an element of, here we said the natural numbers. So in higher levels of math, we could do this here, X bar for all numbers X such that X is an element of the natural numbers. X is a natural number. That's also why we have these symbols. Because instead of having to write this all out, that right there says the exact same thing. And that's what with set builder notation is. I will take this. You don't have to know this. All right. These, I'm going to need to put a sticky note to myself to redo these notes sheets. And then probably if y'all went back and watched the videos from last year, I probably said the same thing. So Questions on this here with this set builder? No? Okay. Okay. I'm going to jump over to this here, because those of you who do have the note sheets, we should have entered in the note sheet page for the new one. Yeah. So on the new note sheet, on the second page, it should have this here. And the reason I want to get to this here is because I don't want to jump to graphing, then back to set builder, and then jumping back and forth. Since we already looked at this here, we can go on and look at these. And we'll look at the top one first, the set of all integers greater than 5. So this is what we're going to start this out with. Yep. Oh, it ran out of staples. Yep. Let's see here. 1, 2. You have one for me? Yep. You're welcome. All right, worked. So, looking at this one here, so we're on the second page. So the set of all integers greater than 5. So we'll start off with brace x bar, the set of all real numbers x, such that what? X is? So what is x? It is greater than 5, but it's also a what? Is an integer. And so x is greater than 5, yes? What's one way that we can write it besides in words? Because we just did some. Or we talk about what? Inequalities. I can use an inequality, yes? That's it. Especially when we start talking about greater than, less than, more than or equal to, use the inequality because it's a little bit easier to work with. Now, the one thing I will say is we can't use intervals. We use inequalities when we talk in set builder notation. Any questions on this here so far? And this will not come up again after this chapter. Set builder is only really used in this chapter so that you're familiar with it, you've seen it, you know what it is, and then we just move on. All right? So any questions on A before we look at B? No questions on A? So let's look at B. Well, set builder, set of all real numbers x such that, well, we have these intervals, yes? Well, let's look at the first one here. Negative infinity, comma, negative 1. So we're talking about as an inequality, this would be what? Is negative 1. That would be the inequality for this here, yes? How about the other one? X is almost greater than negative 1, because we're talking about all the numbers bigger than it, because negative 1 comma infinity is all the numbers bigger than negative 1. So for the description here, we can use these here, because we can say that x is less than negative 1. Or what? X is negative 1. So we're just using those two inequalities. Questions on this here? So we feel all right with this? And if you're wondering probably where I got the or from, because that's just from the statement, because it's saying that this is true or this or this. If it had said and, we would have and. But for this here, we wouldn't actually use and because there is no overlap. Questions on these two here? So let's look at the first one here. So again, with set builder notation, we will start with this here, brace X bar. Now, unfortunately, we can't write it as these intervals, but we can switch it over to inequalities. Now, since they are unbounded, just like the last one, we'll have X is greater than or less than or greater than or equal to or less than or equal to. So for the first one, we're talking about all the numbers that are less than or equal to 1. So here, X is going to be less than or equal to -1. And really, that's the first part of our description. Or we need the other half, 1 to infinity. So we're talking about what? All the numbers that are bigger than 1. So X would have to be greater than 1. Now we know we don't need the equal sign for the greater than 1 because, again, we have 2 parentheses. Yes, sir? We can do that, yes. So we could have said 1 is less than X because we're talking about X being bigger. As long as it's the correct statement that goes the correct way, I will take it. So I will take either one of those. Mm-hmm. Any questions on this here? Be ready for the next one. So again, we start off with X, brace X bar, the set of all real numbers X such that what do we know about X? Is it all real numbers? The set of all except, so we need to, because right now we're talking about all real numbers, yes? So we need to change that. X is an integer. I run out of room. So you guys can keep writing to the side. I just run out of room, so I'm going to have to write underneath it. And what do we know about it? It is not what? It doesn't include -4. So what can X not equal? -4, yes? So how do we do not equals? X is not equal to -4. And that's it, yes? Any questions on this? There is an easier way to write it. I mean, there's different ways like we saw already. Because how do we start this off every single time? This here is what? X is, or the set of all real numbers X, yes? It seems odd that they specify that, because we can change that if we wanted. Because I can say X is an element of the, because if I use Z, Z is the integers, yes? So now it's changed. It's now I'm saying the set of all integers, or the set X is an integer. Essentially is what we did. We changed it from all real numbers to integers such that X same thing. But again, I will take this. I have a feeling one of these, there's going to be one similar to this on the test or review. But instead of saying integers, it will say real numbers. And again, with this here, the set of all real numbers X, such that, yes? If it does say all real numbers, I don't need the integers. I can just say X is not equal to -4. That's it. I think there might be one on the homework that does that too. The set of all real numbers X, such that X is not equal to 5. We can do brace x bar, x not equal 5 brace. That's the answer. Any other questions on these here? Okay. So do we kind of feel comfortable with set builder, or kind of how it works? Because, yeah, there's the same thing. There's many ways we can do it. This here is kind of the bare bones, simple way we can do it. There are other ways that we can do it that make it easier, kind of more simplified, but it doesn't change what we're saying. Are we good with these here? All right. So we'll go back to doing some of the sketch the graph, because I think this is what the actual note sheet started with. Yes? I hope at this point you're comfortable with graphing, hopefully. Because we'll do a few here to go back over it, and then we'll jump, because I know we're jumping around. I don't like it, but it's where we're at right now. So we look at the first one here. We want to sketch this graph, this set builder notation. And if we read the set builder notation, it's saying the set of all real numbers x such that 2 is less than x is less than or equal to 5. What's the only thing we really care about in this whole thing? This here. This is the only real part we care about, because it is the set of all real numbers x, so it's going to be everything between those and might or might not include those. And whenever x is in the middle, we shade in the middle. Yes? Yeah, we will shade one of the circles in, yes. Because our 2 points are 2 and 5, yes? Will both of them be open, both closed, one open, one closed? Because at 2, is it equal to it? So here it's just less, or we just have the greater than. So it's going to be open. At 5, we do have the equals, so it will be shaded in. And since x is in the middle, we shade the middle. That's it. Hopefully, we will only encounter all real numbers x, because if it said the integers, that means we would only be looking at the points here, 2, 3, 4, and 5. Because all the numbers between 2 and 3, 3 and 4, 4 and 5 are not integers. They're rational and irrational and numbers in between. So be good with the first one. Let's look at the next one. The set of all real numbers x such that x is less than or equal to 0, or x is greater than 4. So again, our 2 main points of concern are going to be at what numbers? 0 and 4. So we can put a circle at 0, circle at 4. So will one of these be included? Which one? 0. So 0 will be shaded in. Now, and 4 would not. So at the point 0, are we going to shade to the right or to the left? Left, because x is what? Bigger than 0 or less than 0? Less than. So we want all the numbers that are smaller. How about with 4? To the right, because we're talking about all the numbers that are bigger than 4. And with an or statement, only one of the 2 statements has to be true. So it is possible if they do go towards each other, we would actually end up shading the whole line. Any other questions on this here? Do we want to see another one of graphing? Yes? Let's do one more. So when we look at this here, so we say the set of all real numbers x such that x is less than -2 or x is greater than 0. So our 2 main focus points for this here are where? -2 and are either one of these included? No, so we don't shade either one. Now at -2, we say what? X is less than 2, yes? Less than -2. So we would shade this way here. Questions on this so far? Now the other part is X is greater than 0. So here we would shade to the right because we're talking about it being greater than. And that's it. Any questions on this here? Are you ready for the next one? All right. We can look at least one or two more of these. So is there one of these two in particular that y'all want to look at? We look at number 4. So looking at this here again, we have the set of all real numbers x such that -6 is less than x is less than or equal to -2, yes? What are our two numbers that are kind of the importance for this here? Well, -6 and -2, yes? Here they didn't give them to us on the number line because the homework you're not going to have a number line. But all I'll ask you to do, especially if you're to graph this on the homework, give me a line. Well, I know I'm going to need -6 and I know I'm going to need -2. I'm just going to put those 2 points down. And again, we put -6 to the left because it is the smaller of the two. And we will have circles around those spots because those are our 2 endpoints for this here. Now, will either one of these be filled in? At the -2, we would fill that in. And then we would shade in the middle, because when x is in the middle, we shade in the middle. Bless you. Any questions on this here? We feel a little more comfortable with this? Do we want to look at the last one? Yeah. So number 5, the last one that we have for this here, then we'll move on to, I believe the last part of the note sheet. Is this here. We have the set of all real numbers x such that x is less than or equal to 0 or x is greater than or equal to 10. So our two main numbers that we have are 0 and 10. And at both of these spots, we'll have a circle because it's either going to be open or closed, and then we're going to shade in one direction or the other. Now, are either one of these points included? Both, because at both it is equal to, so on both of these here, we will fill this in. So the first one says x is less than or equal to 0. So at the point 0, will we shade to the right or to the left? Left, because it's less than. At 10, x is greater than or equal to 10. So at the 10, will we shade to the right or to the left? And that's it. And that's all I would expect for the answer. You don't have to put 0 as long as you have the number set up correctly on the number line. That's all I want. Questions on any of this here? Okay. So this is the last part, writing subset and set notation. So I did include it here. I think this was actually in the first number or the note sheet. Writing the whole numbers 50 through 54. So the whole numbers we're not talking about decimals, we're not talking about fractions, we're just talking about what numbers? 50, 51, 52, 53, and 54, yes? Or that'd be pretty easy to write, yes? And that's what's going to be the big thing with writing these. Okay. 50, 51, 52, 53. Now, if it had not said the whole numbers, if it said integers, well, that'd be the same thing. Now, if it said the real numbers, 50 through 54, it's not possible because the number of numbers between 50 and 51 is infinite. Because think of every number that we have going out. I can do 1 over that number, or pretty much make it, or from 0 to 1, we can do 1 over that number. For all of these here, we can do the same thing, just adding 50 to it. So having it between here and here, I mean, there's a ton of numbers that we can have. So trying to do it that way won't work, but we can do set builder as we just saw, because we can do bracket, a set of all real numbers x such that 50 is less than or equal to x is less than or equal to 54. We can write it as an inequality. Is that a feeling? Here's exactly what I was talking about. So we're talking about the real numbers between 0 and 4. I can't write all these out. As I just said, between 0 and 1, we have an infinite number of numbers. So here, writing it as we did the last one's not going to be realistic. But we can use set builder, the set of all real numbers x such that, so the numbers are between what? 0 through 4, yes? So we can write this as an inequality. Because if it is not realistic to try to write them all out, we're going to use an inequality. Might as well just write this down here. Because what's the smallest number x can be? What the biggest is? Now, most likely, I think, reading back at it, it might just do less than on both, but I will take this. Questions on this here? So for these here, if it's not feasibly possible to write them all out, we can use inequalities. Yes, sir?
Can we still do it from the 50 through 54?
Yeah, because we could have said 50 through, or 50 is less than or equal to x is less than or equal to 54, and it would have been the same thing. We would have just also had to specify that x is a whole number. Would be the only difference. So we'd say x bar, x is a whole number, and 50 is less than or equal to x is less than or equal to 54. The integers, negative 100 through 100. Could we actually physically write this? I mean, yes. Would it take forever? Yes. So we can say, use set builder. And also, I think this actually answers the question you just asked. So we just have to say x is an EGER integer and what? Negative 100 is less than or equal to x is less than or equal to 100. Questions on this here? Hopefully this is starting to seem a little bit easier than you thought it was going to be. The prime whole numbers. There's no way we can list this out because even mathematicians and scientists believe that there are an infinite number of prime numbers, but they haven't been able to prove that. If you all are able to prove it, the Riemann's hypothesis, do it, you'll win $1 million. But for this here, we could just stick with set builder. For all real numbers x such that x is a prime whole. That one I just pretty much put it in a sentence and stuck it in there. Actually, we probably could have done that on the previous ones. But that's it. Questions on this here? I'm not too worried about those, but that's it. So that's the end of 1.1. So on the homework, because luckily both of them do have the homework sheet, I did remember to do that. 5 through 14. So 5 and 6, use braces to list the elements of the set. So the set of integers greater than 50. I'm going to be nice. And you can do the same with 6. 7, 8, 9, 10, 11, 12, 13, 14. So like we kind of started off today with, writing it in interval notations with our brackets and parentheses is what it wants for those. 17 through 24. 17 through 20, sketch the graph of the set of numbers. So you're just sketching the graph like we did today. If you do have questions on them, we can start those off first thing tomorrow. 21 through 24, write the set of numbers in set builder notation, converting it from the interval to inequalities and using our brackets. And the same thing is true with 26 and 27. So if you have questions on any of those, please ask. As I throw that on the floor.